Welcome back to the deep dive. Today we're shifting gears a little.
Yeah, a little bit.
Usually, we take a stack of articles, maybe a biography or a trend report, and we just sort of chat about it, keep it pretty casual. But today we are putting on our hard hats. We are walking onto the shop floor.
That's a good way to put it. We are treating this session not just as a discussion, but more like an audio workshop, a seminar, really.
Exactly. We are diving into a very specific, very dense, but I think incredibly important document. It's called BSEN ISO IEC 23894.2024.
It's a mouthful.
It is a mouthful. The full title is Information Technology, Artificial Intelligence Guidance on Risk Management.
And this is, it's the definitive international playbook for how organizations are supposed to handle the risks that come with AI. And we aren't just skimming the surface today. We're going straight into the engine room of this standard. We're going to get Clause 6.
Clause 6. Okay, it sounds a little ominous. Why are we zooming in on just this one section? Why not, the whole document?
Well, if you look at how the standard is structured, the earlier clauses 4 and 5, they really just set the stage.
Okay.
You're talking about principles, governance, the high-level framework. That's all the what and the who. It's the theory. But Clause 6 is the how. It's the actual risk management process.
So this is where the rubber meets the road.
Precisely. If you are a practitioner, if you're the person who is actually tasked with assessing an AI system on, a Monday morning, Clause 6 is where you live.
Right.
It takes you step by step from what are we looking at to how do we fix it, and then how do we keep watching? It is basically the manual for the mechanic.
Okay, so here's our mission for this deep dive. We're going to act as your instructors. I'll try to be the practical voice here, the one asking, okay, that sounds great, but what do I actually write down? What does this look like in an actual meeting?
And I'll take the role of let's say, the structural instructor. My job is to explain why the standard requires these specific steps, how they connect to the bigger picture of AI safety, and how this specific standard ties back to its parent standard, ISO 31000.
Right. And just before we crack it open, a quick disclaimer. We are strictly reporting on what's in this ISO IEC guidance. We're not taking sides. We're not getting into the politics of AI regulation at all. We're just here to help you understand what the document actually says.
We are impartial guides to the text, that's all.
Okay. Let's open the book. We're starting right at the top of the process. Clause 6.1. General.
So 6.1, it basically sets the ground rules for everything that comes after it. And the first and probably the most important thing it establishes is that risk management in AI is not a straight line. It is iterative.
Iterative, meaning we don't just do it once, print out a nice PDF report, and, wash our hands of it.
Exactly. The text explicitly says that organizations should implement a risk-based approach, and that implies a continuous cycle. You identify, you assess, you treat, and then, because AI systems change and the world they operate in changes, you do it all over again. It mentions specifically that the process relies on the AI system lifecycle.
I noticed that cross-reference. It points to ISO IE 22989.2022. It seems like you can't really do this risk management in a vacuum. You have to know where the AI is in its life, right? Like, is it being built? Is it already deployed? Is it being retired?
That's a critical insight, yeah. The risks you face during the data collection phase are completely different from the risks during deployment.
Sure.
If you're collecting data, your risk might be a privacy violation or, say, copyright infringement. But if you're deploying it, your risk is more about bias or a catastrophic system failure.
Yeah.
So Clause 6.1 really emphasizes that this whole process needs to be integrated into those life cycle stages.
Okay.
But there's another nuance in 6.1 that I think is really fascinating. It talks about objectives. It says you need to take appropriate treatment measures considering the objectives of the organization.
I caught that too. It creates this interesting tension, doesn't it? We often think of risk management as the Department of No.
Right.
They're the people who stop you from doing the cool, innovative things. But the standard seems to suggest that risk management is actually about enabling you to hit your goals, but safely.
Precisely. It's about balancing the unpredictability of AI with its strategic value. The text explicitly mentions that AI has issues like lack of transparency and complexity. And because of those unique features, the standard calls for narrowly scoped risk management processes to sit alongside the broader, more strategic ones.
Narrowly scoped. So you can't just have a generic company-wide risk policy and apply it to everything.
No.
You need specific processes for specific AI models because they're so unpredictable.
Correct. You need a microscope, not just a pair of binoculars. You can't apply the same risk framework you use for a simple payroll bot to, say, a generative video model. The ways they can fail are just too different.
And this idea of narrow scoping really changes the game for the person sitting in the chair doing the work, doesn't it? It implies you can't just copy-paste your risk assessment from the last project.
It absolutely does. And this connects right back to that parent standard I mentioned, ISO 31000. That standard provides the generic framework, the skeleton, if you will.
Okay.
But this standard, 23894, is saying when you put AI meat on those bones, the creature looks different. The iterative nature has to be more aggressive because AI is so dynamic. I mean, a bridge doesn't change its structural integrity overnight unless, a ship hits it.
Right. It's static.
It's static. But an AI model can drift. Its data distribution can shift, and its risk profile can change completely without anyone ever touching the code.
That's a great analogy. A bridge is static. An AI is fluid, so your risk management has to be fluid too.
Exactly. And that fluidity, well, it requires more people to be paying attention. Which brings us very nicely to the first real action step in the process. Clause 6.2, communication and consultation.
This is often overlooked, isn't it? I feel like in most technical projects, communication just means sending a few status update emails to your boss or the client.
In traditional IT, yes. But in the context of AI, Clause 6.2 is, well, it's explosive.
Explosive? Why is that?
Because the standard states that the set of stakeholders for AI systems is, and I'm quoting directly here, larger than initially foreseen.
Larger than initially foreseen. That is a very polite, very ISO way of saying you forgot about a lot of people.
It really is. The text explicitly includes unconsidered external stakeholders. It even goes as far as to say the circle of stakeholders extends to other parts of a society.
Wow. This is a huge shift. If I'm building a standard piece of software, like a spreadsheet application, my stakeholders are pretty clear. The finance team, the IT support guys, maybe the CFO. But if I'm building an AI for, say, facial recognition or loan approvals...
Your stakeholders now include people who may never interact with your company directly. If your loan approval AI is biased, it affects an entire demographic of society. They are now your stakeholders. If your autonomous vehicle interacts with pedestrians on the street, those pedestrians are your stakeholders.
The text uses the phrase affected communities. That's very specific. It suggests we need to go out and actually talk to people who might be impacted by this thing, even if they aren't our customers.
Yes, and notice the word choice. It's not just communication, it's consultation. You need to get their views. The standard warns that AI systems can affect people who might not even know the system exists.
That is a spooky thought. Being impacted by a system you don't even know is there.
I'm there.
Think about something like algorithmic pricing. I might be paying more for a flight because of an AI, and I have absolutely no idea. This clause says the company building that AI needs to consider me a stakeholder.
Exactly. It forces the organization to burst its own bubble. You have to communicate with the invisible impacts of your work. It creates a requirement for a feedback loop that goes well beyond your user interface.
So step one in this whole workshop is basically broadening your circle. You have to talk to way more people than you think you do. You have to find the people who don't even know you exist.
Correct. And once you've established who you're talking to, you have to establish what you're actually looking at. And that brings us to Clause 6.3. Scope, context, and criteria.
Okay, this seems to be divided into a few chunks. Let's start with 6.3.1 and 6.3.2, which deals with the scope.
The scope is your boundary. You can't just assess AI in general. It's too vague. You have to assess this specific system in this specific context. The standard says you must define the objectives and purpose of the AI systems developed or used.
And it also mentions identifying where AI is being used. Now, that sounds obvious, but in a big company, shadow AI is a real thing.
Oh, absolutely.
People are using tools the IT department doesn't even know about. Marketing might be using a generative tool for ad copy. HR might be using a tool to scan resumes.
Exactly. And if you don't know it's there, it's outside your scope. And that is a massive unmanaged risk. So 6.3.2 is all about drawing that circle around the specific tasks and responsibilities. It's about taking inventory. You cannot manage the risk of a system you haven't even identified.
But the real meat of this section, the part that I think requires the most brain power, is in 6.3.3, external and internal context.
This is where you map the terrain.
Yeah, I spent a lot of time looking at Table 2 and Table 3 in the source text here. These are essentially just checklists of stuff you need to worry about.
Let's break down the external context from Table 2 first. What stood out to you there?
Well, usually when you talk about external context, it's just, competitors or market conditions. But here, it lists regulators, civil organizations, individuals, and, there it is again, affected communities and societies.
It forces the organization to look outside its own office walls.
Yeah.
It's acknowledging that an AI system operates within a social fabric, not in a vacuum.
And it gets very specific. It lists legal requirements related to AI and ethical guidelines. That second one is tricky. Ethical guidelines issued by government, academia, or civil society. That implies you have to be reading academic papers to know if your AI is risky.
It implies you need to be aware of the standards of behavior that are expected in the field. Ethics isn't just a gut feeling in this context, it's about published guidelines. If academia and civil society organizations have established that, say, using facial recognition for X is unethical and you go ahead and do it, you are ignoring the external context, you're just inviting risk.
It also lists a fascinating point: societal and political implications of the deployment of AI systems.
Yeah, that's a heavy one. Political implications.
And it mentions stakeholder perceptions regarding, and this is a quote, lack of transparency, opaqueness of AI systems, or biased AI systems.
This is so crucial. Even if your system is perfectly fair, if the public perception is that AI in general is opaque or biased, that perception is a risk source. The standard is telling you that public trust is a part of your external context. You have to account for the fact that people might be suspicious of your tool before you even launch it.
So if I'm launching, say, a chatbot for mental health, even if it works perfectly, the public fear that it might sell patient data is a risk factor I have to actively manage.
Exactly. The environment you're operating in includes the mood of the public. You are operating in an ecosystem of trust, or more likely, distrust.
Okay, so that's the outside world. Now let's look at table 3, the internal context. This is about looking in the mirror.
Right. This is all about your capability. Can you actually handle the risks you're about to take on?
The first thing that really hit me here was organizational culture. The standard literally asks, can the culture shift to support new responsibilities?
Because AI governance requires a completely different mindset. If your company's culture is move fast and break things, you are going to struggle with a standard that demands narrowly scoped risk management and societal impact assessments.
It forces a culture clash, right? If your engineers are only incentivized on speed of deployment, and your risk team is trying to follow this ISO standard, you have a fundamental problem in your internal context.
Precisely. And if that culture isn't aligned, that is a risk source in and of itself. The risk isn't just in the code, it's in your team dynamics.
And it gets very practical about resources. It lists capital, time, people, intellectual property, but then it gets specific to AI, data science knowledge.
That's a huge one. Do you actually have the people who understand the math? Not just people who know how to run the Python script, but people who understand why the code works, or, more importantly, why it fails.
The standard also lists data, information systems, and information flows as a key resource. So if your data is a mess, if it's unorganized, unlabeled, or sitting in a dozen different silos, your internal context is high risk. You can't build safe AI on a foundation of dirty data.
And the final bullet is interdependencies. AI doesn't sit on an island. It connects to everything. It pulls data from legacy systems. It pushes decisions out to new apps. All those pipes, all those connections are part of the context.
So once you've mapped the outside world, your external context, and you've mapped your own capabilities, the internal context, you have to set the rules of the game. That's clause 6.3.4, defining risk criteria.
This is the yardstick. How are we going to measure if a risk is high, medium, or low?
Usually those criteria are pretty standard. You know, if it costs us $10,000, it's low. If it costs $1 million, it's high.
Exactly. But for AI, the standard, and it references table 4 here, notes that the yardstick itself has to be different.
How?
One word: uncertainty. The text says you must account for uncertainty in all parts of the AI system. That includes the data, the software, and the models themselves.
We're going to talk about this more in the assessment phase, but it sounds like the standard is basically admitting that AI is fuzzy. It's probabilistic. You can't just say, if X happens, Y will happen. You have to say, if X happens, there's a 70% chance of Y.
And that makes defining your criteria very, very hard. The text also highlights human-in-the-loop aspects. Your criteria need to account for how humans interact with machine. If a human is supposed to check the AI's work, but they get lazy and just start clicking approve every time.
That's automation bias.
Right. And that completely changes the risk profile. So your criteria have to account for that human element.
And time-related factors. The standard mentions that AI is a fast-moving technology domain.
Which means your risk criteria can expire, like milk. A risk that is acceptable today might be completely unacceptable in 6 months because the technology has improved. Or, more likely, the regulations have tightened. It says measurement methods must be consistently evaluated. You can't use a 2020 yardstick in 2026.
Okay. So we've built our team of stakeholders, we've defined our scope and context, we've got our yardstick, now we get to the core of the workshop. Clause 6.4, risk assessment.
This is the heavy lifting. This section is divided into 3 parts: identification, analysis, and evaluation. Let's start with 6.4.2, risk identification.
The mission here is to find all the possible risks. The standard suggests using a sample catalog of AI-related risk sources. It's basically saying don't start from a blank page, look at what other people have already found.
And it breaks identification down into finding your assets and finding the sources of risk.
Let's talk about assets 6.4.2.2 first. What are we actually protecting?
In traditional IT security, you're protecting servers, laptops, and customer databases. This standard goes so much further. It lists organizational assets like reputation and the models themselves, yes, and individual assets like personal data, privacy, and safety. But then it adds that third category we keep seeing again and again, societal assets.
I have the list right here. The environment, sociocultural beliefs, community knowledge, educational access, and equity.
Just stop and think about that for a second. Community knowledge is listed as an asset that your organization needs to protect from your AI.
Can you give me a concrete example of that? What does threatening community knowledge even look like?
Well, imagine you're deploying an AI that mines indigenous knowledge or artwork to train a generative model, and you do it without consent or attribution.
Okay.
Or an AI that distorts historical facts in a way that erases a specific community's history from the narrative. You are damaging a societal asset. You aren't just hurting a customer's wallet, you're hurting a community's heritage.
That is a profound shift for a risk manager. Suddenly, I'm not just protecting my company's bottom line, I'm protecting educational access. If I build an AI tutor that's only affordable for rich kids, I'm technically threatening a societal asset, according to this.
Exactly. It frames the organization as a custodian of these broader values. And once you know what you are protecting, you have to look at what's threatening it. And that's clause 6.4.2.3 and the amazing Annex B, which lists the risk sources.
I spent a lot of time in Annex B. It is a laundry list of nightmares. Let's unpack a few of them.
Let's do it. What stood out to you?
Okay, first one, complexity. The text mentions that AI handles complex environments, like autonomous driving, where, and I'm quoting, not all states are predictable.
Right. In a standard computer program, you can map every possible input to an output. If A happens, then B happens. With AI in the real world, you just can't. A leaf blowing across the road in a specific lighting condition might look exactly like a rock to the sensor. That unpredictability is a risk source in itself. The sheer complexity of the environment is the enemy.
Then there's lack of transparency. The classic black box problem. The text calls out explainability issues. An ML model might have behavior that is difficult to understand by inspection.
And if you can't understand it, you can't trust it. And that leads to huge risks in accountability. If the AI denies someone a loan and you can't explain why, that is a massive legal and reputational risk source. You can't just say, the computer said no. The standard identifies this opaqueness as a primary driver of risk because it prevents you from auditing your own work.
Automation level. This one was interesting. It talks about the handover.
Yes, the transition from the system to the human agent. If the AI handles 99% of the driving but needs a human to take over in that last 1% of a crisis, that handover moment is a massive risk source.
Because the human might not be paying attention.
They might not be paying attention. Or they might have automation bias where they just trust the machine so much they don't question it.
It creates a complacency loop, doesn't it? The better the AI gets, the worse the human gets at supervising it.
Exactly. The competence of the machine degrades the competence of the human operator. That is a risk source identified right there in the text.
And then, of course, the big one. Machine learning issues, all the data stuff.
The classics.
Data quality, unrepresentative data leading to bias, data poisoning, and continuous learning.
Continuous learning is a really tricky one. If your system continues to learn after it's been deployed, its behavior is constantly changing.
Right.
That means the safety checks you did on day 1 might be completely invalid by day 100. The risk source is the change itself. The model is a moving target.
And one last one from Annex B that just surprised me. Hardware.
Ah, yes.
It mentions soft errors caused by radiation. Are you serious?
It does. High-energy radiation-like cosmic rays from space causing bit flips in memory cells.
Wait, really? We have to worry about space radiation hitting our servers.
Well, because AI processing is so intensive and often relies on these massive parallel processing chips, a single hardware glitch can propagate through the model in completely unpredictable ways. A single bit flip in a crucial neural network weight could drastically change the output. It also mentions decommissioning issues, like how do you safely throw away a machine that has learned sensitive patterns from data?
Wow. Okay, so we've listed all these sources, we've found our assets. Now we need to identify the events and consequences. 6.4.2.6.
This is where we play out the movie. If this source acts on this asset, what bad thing happens?
And the standard gives us some tools for finding these events: historical data, field trials, stakeholder reports, and interviews.
Field trials are key here. You can't just simulate this stuff in a lab. You often have to run it in a controlled real-world environment to see all the weird edge cases that pop up.
And when looking at the consequences, I want to point out the specific list of bad things the standard warns us about.
Please do.
It's not just lost money. It includes things like investigation time, lost opportunities, threats to health and safety, and customer litigations.
And notice the emphasis it places on disparate impact. It asks you to identify differences between groups who experience the benefits and groups who experience negative consequences.
That is the fairness check. Is this AI system great for the rich users but absolutely terrible for the poor ones? That's a risk event.
Exactly. It forces you to disaggregate the impact. You can't just say, well, on average, everyone is happy. If 90% of people are happy and 10% are completely devastated, that 10% is a critical risk event.
Okay, so we have identified the risks. Now we have to analyze them. Clause 6.4.3, risk analysis.
The standard makes a really important distinction here between a business impact assessment and a societal impact assessment.
This feels like the pivotal moment where the standard really diverges from everything else I've seen.
I think so too. Yes, you can have a risk that is low impact for the business. Maybe it's a small fine, something the company can easily absorb.
A rounding error.
A rounding error. But that same risk could have a catastrophic impact on society, like eroding democracy or privacy. The analysis must capture both. You can't just hide the societal damage because it doesn't hurt your bottom line this quarter.
It lists specific factors for individual impact, potential bias impact, potential impact on fundamental rights,
and jurisdictional and cultural environment. A facial recognition system might be a low risk in one country with very loose privacy laws, but an extremely high risk in the EU with GDPR. The context completely changes the analysis.
Now, here's where it gets really, really interesting for me. Likelihood. 6.4.3.3.
Ah, yes. This is the controversial part of AI risk management.
The text itself warns about the difficulty of calculating probability.
It does. It says there can be significant technical economic heuristic issues that make decision-making based on likelihood very difficult.
Let's translate that from ISO speak. It means you often have no idea how likely a specific failure is.
Right. In traditional engineering, you can say, this bolt fails once every million hours. We have the physics for that.
Yeah.
With a large language model or a complex neural network, you just don't know the failure rate because you don't really know the internal logic. It's non-deterministic.
So the text basically says, sometimes you just can't calculate a margin of error accurately.
Which implies that for some AI risks, you shouldn't rely on likelihood at all. You should focus on consequence.
Okay.
If the consequence is mass discrimination or destabilizing the financial market, it doesn't matter if you think it's unlikely. The uncertainty is so high that you have to treat it as a serious threat. You assume the worst because you can't possibly calculate the odds. This is the precautionary principle baked right into a technical standard.
And that leads us right into 6.4.4, risk evaluation. This is the decision point. You take your analysis and compare it against the criteria we set way back in 6.3.
It's a simple pass-fail check. Does this risk need treatment? If the answer is yes, we move on to clause 6.5. If no, we just record it and monitor it.
Okay, let's go to clause 6.5, risk treatment. We found the problem. How do we fix it?
The standard gives us a whole menu of options in 6.5.1 and 6.5.2.
Let's run through the menu. Option 1, avoid the risk.
Stop the activity. Just don't launch the feature. If the facial recognition model is too biased, you simply don't ship it. This is often the hardest one for businesses to swallow, but it's also the safest.
Option 2, remove the risk source.
Clean the data. Fix the bug in the code. If your data set has too few women, you go out and you collect more data on women. You attack the root of the problem.
Option 3, change the likelihood or consequences.
This is a big one. You could put a human in the loop to catch errors. That changes the likelihood of failure. Or you could limit the AI's access to bank accounts. That changes the consequence if it fails. If the AI hallucinates, but it doesn't have the keys to the database, the consequence is just embarrassment, not catastrophic data loss.
Option 4, share the risk.
Right, buy insurance. Or write contracts that shift the liability to your vendor.
And option 5, retain the risk.
Basically accept it. You say, we know this might happen and we've decided we're okay with it. This usually requires sign-off from very, very high up in the organization.
But there is an option 6 that is really fascinating. Take or increase the risk.
Yes, taking or increasing the risk in order to pursue an opportunity.
That sounds completely wild in a safety standard. Go ahead, make it riskier.
It's not about being reckless. It's about acknowledging that innovation itself requires risk. Maybe you deploy a beta version of a product to a small group of users. That increases the risk of failure in the short term. But you do it to gather data that makes the system much safer in the long run. You're pursuing an opportunity. It's a trade-off.
And 6.5.2 calls this the balancing act.
It creates a requirement for a cost-benefit analysis. You have to design a treatment to reduce the negative consequences to an acceptable level. But the standard explicitly says you are also trying to increase the likelihood of positive outcomes.
So risk treatment isn't just about shielding yourself from bad things. It's about sculpting the product. It's asking, how much risk can we stomach to get this reward?
Exactly. And once you've picked your option, 6.5.3 says you have to prepare and implement the plan. And documentation is absolutely key here. You need to verify that the fix you put in place actually worked.
Which flows perfectly into the next part, clause 6.6, monitoring and review.
The continuous watchfulness phase.
The standard says you can't just set it and forget it.
Especially not with AI. We talked about continuous learning earlier. But even if the AI itself doesn't learn, the world changes around it. This concept is called drift. Data drift or concept drift. The model was perfect for 2024, but in 2026, user behavior has changed, and now the model is obsolete or even dangerous.
The text highlights a specific need to assess the trustworthiness of the AI system. And this part was really interesting. The organization must collect and review publicly available information on similar systems on the market.
That is a very, very smart clause. It means that if your competitor's AI crashes and burns because of a specific data issue, you are now obligated to look at your own system and ask, could that happen to us? You have to learn from the market's mistakes. You can't just play dumb.
It effectively crowdsources risk awareness. If a new vulnerability is found in the underlying technology, like large language models in general, you have to review your specific implementation.
And if the residual risk changes or if your own risk acceptance criteria change, the process loops all the way back.
Back to the beginning, the cycle starts all over again.
It never ends. That is the burden of Clause 6.
Finally, we reach the last step, Clause 6.7, recording and reporting. The paperwork.
The paper trail.
And it lists a very comprehensive set of requirements for what you must record. Description of the system, the methodology you use, the intended use.
The identity of the persons who carried out the assessment.
Right. Names on the paper. Who signed off on this?
The why here is all about traceability. If something goes wrong 3 years from now, you need to be able to reconstruct the decision-making process. Why did we think this data was safe? Who said this level of bias was acceptable? You need to be able to answer those questions in court or to a regulator.
It mentions using a common template for this.
Which is about standardization within your own organization. You don't want the marketing team doing a risk assessment on the back of a napkin while the engineering team is using some specialized software. You need a common language.
And the final check in the reporting section is, did we meet the degree objectives? Basically, do we actually manage the risk we set out to manage?
It sounds dry. But that reporting clause is what keeps executives out of jail and keeps products from being banned by regulators. It is the proof that you did your due diligence.
So we've walked through the whole machine, from 6.1, the iterative process, through finding your stakeholders, setting the scope, the deep assessment, the treatment, the monitoring, and finally, the reporting.
It is a comprehensive journey, for sure.
As we wrap up this seminar, let's do a quick instructor summary. What are the key takeaways for you from Clause 6?
For me, the biggest takeaway is the breadth. This is not traditional IT risk management. It forces the organization to look at society, at fundamental rights, at ethical guidelines, you are not just managing server uptime, you are managing your impact on the world. It sort of democratizes the risk assessment by including affected communities.
And for me, it's the sheer detail that's required in the assessment. The acknowledgement that AI is complex, it's opaque, and it's constantly changing. You can't just use your old school probability charts. You have to get into the weeds of data poisoning and hardware errors and societal assets. It feels like it requires a Renaissance person to do this job. You need to know math, ethics, law, and sociology.
It really emphasizes the human in the loop. It emphasizes transparency, and it forces you to be honest about what you don't know.
And that leads us to our final provocative thought for you, the listener.
We mentioned this briefly in the risk treatment section. The standard explicitly allows, and even codifies, taking or increasing the risk in order to pursue an opportunity.
In a world that is, right now, absolutely obsessed with AI safety, where everyone is screaming safety first, this very serious standard acknowledges a reality. Innovation is risky.
So the question to think about is this. How many organizations are actually going to use that clause? Are they going to use Clause 6.5 to justify dangerous experiments in the name of opportunity? And conversely, does this framework actually provide a safe, structured way to do dangerous things?
Is it a brake pedal, or is it a steering wheel for driving very, very fast? Something to mull over.
Indeed.
We hope this deep dive workshop into ISO IE 23894 has been helpful. You have your certification of completion? Well, virtually anyway.
Class dismissed.
Thanks for listening. We'll see you next time.